This video will cover the use of inductive and deductive reasoning. By the end of this video, you will be able to use both inductive and deductive reasoning to make conjectures. In addition, you will be able to confidently employ these two types of reasoning to form logical and informed conclusions. Inductive reasoning is a method of drawing general conclusions from specific observations. When you use inductive reasoning, you make a conjecture, which is an educated guess or hypothesis based on the observed patterns or trends. While conjectures are not always proven true, they can guide further investigation and are essential in scientific and mathematical research. Let's look at the steps to using inductive reasoning. Step 1. Observation. This step requires us to carefully observe a set of specific instances or examples related to the problem at hand. We should pay attention to patterns, trends, or recurring characteristics in the data. Once we have made our observations, we can move on to Step 2. Proposition. Based on the patterns or trends we have identified, we need to propose a general statement or hypothesis that summarizes the observed pattern. It is important to note that this conjecture should apply to all instances of the problem, not just the ones we observed. Step 3. Inductive reasoning, while not providing definitive proof, allows you to test your hypothesis or conjecture by looking at additional examples or conducting further experimentation. Step 4. If the evidence supports your conjecture, it becomes a strong hypothesis. However, if new evidence contradicts it, you may need to refine or revise your initial conjecture. Let's look at an example. A biologist observed that a specific type of flower attracts more bees compared to other flowers in the same area. What conjecture can be made based on this observation? First, apply Step 1. Gather observations. The biologist observed that a specific type of flower attracts more bees than other flowers nearby. Next, apply Step 2. Formulate a conjecture. Based on this observation, the biologist can make the conjecture that the unique features of this flower, such as its color, scent, or nectar production, make it more appealing to bees. Now let's apply Step 3. Test your conjecture. The biologist can conduct further experiments to compare the attractiveness of different flowers to bees and gather more data to support or refute the conjecture. Last, Step 4, refine and revise. If the experiments consistently show that the specific flower attracts more bees, the conjecture becomes a more robust hypothesis about bee behavior. Inductive reasoning is a useful tool for making educated guesses and developing hypotheses based on observations and patterns. However, it is important to note that these conjectures are not absolute truths, but rather provide valuable insights. They can guide further exploration and research, helping to deepen our understanding of the world around us. So, when encountering word problems or real-life scenarios, consider using inductive reasoning to make informed guesses and develop hypotheses that can contribute to your knowledge and learning. Deductive reasoning is a method used to draw specific conclusions based on general principles, facts, or definitions. It involves starting with a general premise and then applying it to a specific case in order to draw logical conclusions. Step 1. The first step in deductive reasoning is to identify the general statement, fact, or definition that applies to a broad category or group of items. This provides a foundation for the reasoning process. Step 2. Once the general premise is established, the next step is to examine a specific instance or case that falls under the category defined in the general premise. This specific instance will help to validate or refute the general statement. Step 3. Use the general premise to deduce specific conclusions or characteristics about the specific case. This involves applying logical reasoning to draw conclusions based on the given general premise. Step 4. Based on the deductions made in Step 3, make a conjecture or educated guess about the specific case. This involves using the logical inferences made to form an informed hypothesis or prediction about the specific situation. Overall, deductive reasoning involves using a general premise to logically deduce specific conclusions and then making educated guesses based on those deductions. Step 1. General premise. All mammals give birth to live young. Step 2. Specific case. You encounter an animal in the wild. When encountering an animal in the wild, based on the general premise that all mammals give birth to live young, there are several aspects that can be discussed. One can observe and analyze the reproductive behavior of the animal, determining if it gives birth to live young or lays eggs. Additionally, one can examine the characteristics and features of the animal to identify if it possesses typical mammalian traits such as mammary glands, hair or fur, and a warm-blooded metabolism. By considering these factors, one can draw conclusions about the specific animal encountered in the wild and classify it as a mammal or potentially explore further research to understand any unique adaptations or variations within the mammalian category. Step 3. Apply deductive reasoning. Animal falls under the category of mammals. Deduce that it gives birth to live young. Step 4. Formulate the conjecture based on the deductive reasoning. The conjecture that the specific animal encountered in the wild is likely to give birth to live young. Deductive reasoning is a valuable tool that allows us to make informed conjectures based on established principles or facts. By following the steps outlined in this handout, you will be able to confidently apply deductive reasoning to draw conclusions and make educated guesses in various word problems and real-life situations.